Okay. I think we're live. As always, let's go ahead and do a little 10 print. Welcome to the stream. 20, go to 10. Oh, go to 20. 20, go to 10. Run. Okay. Um, yeah. We're gonna do just as the title says, connecting to the commodore 64 with Python. And let me actually, it's a bad look. Let me go ahead and check. Goodness, my what's it called? YouTube.com. Let's check our studio tab and see notifications. Nothing new. I released a short. I put out a YouTube short recently, and I'm pretty proud of how it did. It's got a really good percentage view time, really good views. 1,000 views, which sometimes we tend to think of it as like, oh, that's like not good, but I feel like if you take a step back and think about like, okay, giving a 1-minute presentation to 1,000 people, like that's 6 hours of human life that I got from people, which to me is it is insane. To me, it's insane. I'm quite proud of that. Sorry, the view is all messed up. I'm dilly-dallying. Let me get to let's check out the live. Oops. Let's get to the control room. Let me listen to it real quick. Okay, yep, connect your encoder. Yeah. Should be connected. Okay, perfect. Yeah, we're gonna be 10 print controlling this with Python. That's what we're gonna be doing. Here, let's just take an inventory of where we're at. Projects, Commodore 64 shenanigans, CD control from afar. Yep. What did we want? We wanted protocol test. So the general idea is that, and let's open up our little explain scene. Okay. So the general idea is that we're communicating with the Commodore 64 from my computer with a Python program over Wi-Fi with like a simulated virtual modem connection. Now the issue is we're just sending raw bytes back and forth, which that works for a while, but I want a more robust way to do things. So I'm introducing a communication protocol. I'm writing my own protocol. And here it is. It's it's a 256 byte packet. We've got our nice basic, what's it called? I got our like headers, and then we get the amount of data in it. We have a couple different things, and I believe I got part of the way through implementing a quick ping. So yeah, so as the program is now, and I'll give it just like 2 bumps. As the program is now, I've defined a class for a packet, can represent itself and stuff like that, and like turn itself into bytes kind of thing. And I'm sending a ping, and then ending the program. That's the idea. And I wrote, so this is the program that we need, because okay, so on like normal computers, you have to open up, like you have to tell the computer, hey, I want to communicate over network. And I'll tell you, my eventual end goal is to run Ansible automation on a Commodore 64. I just think that'd be funny. And the way I'm going to do that is, so normally you use Ansible over something like SSH. And, we obviously can't run SSH on the Commodore 64. Maybe you can, now that I say that. Maybe that exists. But instead, I'm going to make something that acts like SSH and write a connection plugin on Ansible to do that kind of thing. So let's get to it. So we close our network communication device, and then we open it back up. And this is a very common pattern in programming, where you'll be treating devices like a file. So, okay, you may have heard this idea that everything on a Linux machine is a file. And where does that come from? Well, I don't know, but I think it's because the ideas behind reading a file have a very nice analog, a nice one-to-one matchup between reading a file and reading a sheet of paper, right? Like you pick up a sheet of paper, you open a book, okay? You can do lots of things with this book. You can open the book to page 1. You can open the book to a random page. You can start reading it top to bottom. That's of course how it works in the English language. Doing this with a file, it makes sense, right? You open the file, it's got a series of bytes in a linear order, right? A book has a series of words in like a linear order, and you can just read through it. And it very much makes sense to interact. Well, it doesn't make sense necessarily, but the idea of treating everything as a file, right? That you can open, read, and write to it, and it'll handle that in different ways. It makes very intuitive sense to people, I think. Now, I wonder if there's a way to do this, to interact with outside devices, you know, in a way that's not like a Unix file system. I'm sure that it exists on, some OS out there. I'm not a network guy. I'm not really an OS guy. I'm just kind of winging it, to be honest. Like this network protocol, man, I have no idea if this is good. It's probably very primitive. Probably some network engineer is going to take one look at this and go, oh my God, what an idiot. But I don't know. I think it'll work. Anyways. So yeah, so the Commodore 64 program, it just opens up the network device for communication. Oh, and that reminds me. It's a virtual Commodore 64, so I have to configure the virtual hardware. So hardware, expansion, RS-232. I think I have it in VIC. Let's try up 9600. I don't know. And yeah, that's all good. And then the UART modem is TCP, baud rate 300. Oh, I don't know if that's right. I think I can bump it up to 600. But I don't know. We'll see if it's outputting gibberish. Otherwise, we'll be fine. But okay. So we've closed the device for safety, closed the file for safety, opened it back up to read, and then we read a byte from the input. If it's equal to nothing, oops. If it's equal to, oh man, Commodore 64, the keyboard layout is not the same. So I always forget how to type in even like simple keys like the equal sign. Like I can't find it, man. Oh, there it is. It's ring finger. Okay, so yeah. If if the byte that we got is empty, then go to 20. Just repeat. We're just gonna get bytes forever until we get some data. And then we'll say that the true value of the wire, that's what W means, W $, is, the car value mapped to a number -1. And the reason we're doing this is because something about this communication right here, something about this is broken and it's refusing to send 0 bytes. Maybe I'm stupid, right? That's a very real possibility, but for now, I don't care. I don't care to troubleshoot. I'm just sending it. And ooh, let me check if my effects are actually on or not. Turn effects on or off. Input, effects. Are they on? Okay, so they're on. They're on. Okay, sorry, they were on. I turned them off. Let's go to it. Yeah, so it can't send the number 0, so I just increment everything by 1, and then on the server side, and then decrement it on the Commodore side. And that just is gonna have to be the way it is. Okay, so we get the wire value. I want to just go and print it with a space afterwards. And then once we've printed it, just go to the end. All right. So it should send our like packet information and then AA. So let's Python protocol test. Okay, so it's sent 222. Don't know what that is about. A bunch of 2s. And then it stopped. Oh man, I bet the baud rate is all kinds of messed up. Okay. Here, let's look it up. Commodore 64 baud rates open file. I don't know. I don't. Oh man. Oh man. What? What? Control register. Control register? I don't remember if 7 is 01, 7 bits. Oh man, dude, I don't know. I don't know. Okay, 7 is 600 baud. And that's what I have it set to, right? UART modem. All right, let's go to the modem. 600. All right, let's go reset the connection and let it let it rip once more. Let's end our program. Run it again. Dial it again. Okay, still getting straight twos. That is concerning. That is real concerning. I wonder why it worked last time. Like, just to be clear, I am in. Is this loadable? Oh, this might not be the real Commodore 64. It might have been Dolphin DOS. Okay, let's just input it again. I'm sorry. I reset the machine. Let's go down here. 10, close 1, open 1, 2, 0, sure, $7, 20, get from, oopsies, device 1 into wire as a string, and if the wire string is, goodness, oh man, we're in quote mode, aren't we? Is equal to blank, then go to 20. We're going to get the real wire value, and then subtract 1 from it. And then we're just going to print that value, the space after it, no new line, and then go and start getting more bytes. Syntax error in 10. Whole point is in fact not, what's it called? Not a basic routine or whatever. Go again. All right. Run it. 22222. Okay, let's just, you know what? We're just going to bump it down because I feel like I've made it work. Or you know what? Here's a theory. Vic 1011. Go again. Nope. Okay. 222222222. All right, that's not good. Vic 1011. Real-time clock. Connection mode internal. Don't know if that's right. Let's hit another reset now that we changed it to Vic 1011. Sorry to keep having to, input this again and again. That's just the nature of programming on a setup like this, is that, I'm a fool and I sometimes forget how to do things. And here's the reality. I might have this program wrong. And I said we were going to switch to 300 baud, didn't I? 300 TCP. Right. Save and then reset. Okay. So we're going to open it at 300 baud. And then just going to get something from it. If $sign is equal to empty quote, then loop W equals the ASCII value. I don't know actually what ASC means. I assume it means ASCII or something like that, but I'm probably wrong. Oh, I'm in quote mode. Gosh darn it. List. What on earth happened here? Uh-oh. Something is broken because I'm typing keys. List? Nope. Oh. List? What happened? All right. Did the core break? What the heck? Let's do some Mr. Maintenance. I haven't done this in a minute. Let's go ahead and run just the update script. Because, the keyboard says it's fine. I was using it earlier today. Where is it? Save core. Do I have to exit, like, out of the core? Core, reboot. Maybe it's this. Yeah, this should get me back to just the main screen. The whole system is rebooting. And let's go ahead and do, what is it? Scripts. Yep, that's okay. Now let's update all and see what happens. I suspect that something is wonky for some reason. Either way, running update all, it'll be good just to make sure that everything else is up to date. So that's what we'll do. In fact, I haven't even seen, I didn't even see a Commodore 64 update go in there. And let's reboot just one more time. Sorry, this is boring. My bad. But yeah. Well, you know what? While it's doing that, let's go to computer, Commodore 64. Let's go. And of course, man, I really need to set my configuration to NTSC because, man, every single time I stream, I'm having to change audio video to NTSC. Hardware. Bam, bam. All right, I know the modem setting is going to be correct. And it's not, man, it is immediately typing nonsense again. Like, what is happening with that? Okay, let's also make sure we're in Dolphin or in the standard system ROM, not Dolphin DOS. Man, something is wrong because this is not what I'm typing. Maybe unplug the keyboard, plug it back in. Oh, I don't know what that was. Clearly something in the connection was wrong because it's working now. Who knows? Maybe, I know that Mr. is running on some pretty constrained hardware. So maybe it's something to do with that. Who's to say? Get from oopsies. #1, man. W. I need to go back to the keyboard trainer. I need to spend some time, studying the blade, if you will, and get fast at typing my symbols again because, man, I just do not have it down on this new keyboard. But that's whatever. We all learn at different rates, and it's, the bottleneck of any programming task has never been typing, right? Like, that's one of the things I think about all this AI stuff is like the primary bottleneck of any of my programming tasks ever has never been typing. I don't know if that just means on the pleb. It's outputting real numbers again. Beautiful. Yeah, so the goal, it should output 1420 6565, and you can see it right in the middle. One in like the middle line, about midway through the line. 1420 6565. Okay, so now that we've got this set up, I've been streaming for what, 20 minutes, and that it took me that long to get things set up. Geez, I should really start doing this beforehand or something. But look, I'm gonna BRB. I'm gonna grab my laptop so I can have chat set up just in case there's someone in here. If you're in here and I've neglected you, I'm so sorry. But I'll see you in a moment. But I'm gonna go pee and do that real quick. So BRB. Where's my laptop? Mm. Okay, I'm back. I'm back. I don't have chat open yet. Let me get it open. Oh, group chat popping off. I never open my Mac, so I always come back to like 10 messages. Let's see if it's anything good. Okay. All right. Let's get cracking. Let's get back to it. Oh, and I need to open up chat. Look, I'm the worst streamer of all time. I'm a monkey after all. Maybe I'm the best ape streamer of all time. And the worst human streamer of all time? Can I be both? Am I allowed to be both? Or is that role already taken? I bet some and I bet there's already some ape streamer out there, man. I'm not into streamer lore like that. Alright. Live dashboard, top chat. Okay, no viewers as always. Not a big deal. Let's keep grinding. Let's get to it. Protocol test. Okay, so we want to send a byte. Okay, so actually here, let's go to the explainer screen because I want to explain something. So the goal is to kind of bootstrap this protocol from like this dead simple Commodore program that I have on screen. I want to like, man, I want to somehow like, okay, there are these techniques to inject. Oh, I already know this. What do you go away? Yeah, go away. Hey, some scripts. Don't want to leak that. I was Googling Zen Buddhist concepts. Overwatch help. Yep, making jokes. Okay. Anyways, um, I know there are techniques to be able to inject, programs in. I think it would be really cool to like have the order where I'm able to, start with like step one, 5, 4, or 5. Oh, oops. Oops. Where'd it go? Okay. 4 or 5 5-line program that injects long program. So I think it'd be cool to have like a 4 or 5-line program that'll inject a long program and run it. And then the long program is the SSH thing, right? Like that's kind of my idea. I don't know if it'll work. And I think it might be more hassle, than it's actually worth. Because if you think about it, okay, my goal is automation of the Commodore 64. SSH is how big is an SSH binary? Like here, which SSH? Okay, ls-h user bin SSH. Okay, HA. Oh, it's L. Okay, so it's 767 kilobytes. That's a lot of kilobytes. Like that's more. I think that's way. That's actually not. Not. But that's a huge program. On the Commodore 64 scale. So I think we're actually good to start off with the longer program. So, okay. So in this program, we start here. Now on line 40, I want to say instead, we want to start doing our like logic. So if w is equal to 1, then okay, let's say line 100 is our like packet reading script. Okay, otherwise go back. Okay. And on line 100, I want to say if okay, so we got a byte. We got a byte 1, which means that the next byte we have our packet structure over here. The next byte we get is going to be the type. So, all right, let's say get from the program. And okay, basic variables can be 2 letters long. So I'll say W, and what did I call it? Command. So WC, what color? WC equals get 1 WC. And then we'll dispatch on our various types. So I'll say rem get command. Okay. So 110 if and here actually I want to do add some space here. WC equals ASC W $-1. Okay. W okay, something's wrong again. And that's really annoying. I wonder why that's happening. I'm wondering if I have some like screwy keyboard configuration set up where like I don't know, where if I like double press one of my layer buttons, it'll lock it. That's completely plausible. I didn't spend much time setting up my keyboard. I just kind of rocked with the defaults, to be honest. So WC equals ASC WC $. Backspace, close paren, backspace, colon. Okay. And then honestly, let's just shorten it so it fits all the way on one line. Get CMD. Okay, beautiful. So line 110 is where we'll dispatch on our commands. So if WC, oh, it's -1. It's -1. Parentheses -1. Parentheses -1. Okay, so 110. If WC equals 1, then let's set this up. If it's 1, then we have a data packet. This is low-key gonna depend. Well, we're gonna have like I'm gonna have like a ton, whether we're gonna have to have like a ton of like state set up beforehand. So okay, so let's just start off with a very simple. If it's 4, oh my gosh. If it's 4, then let's go to line like I don't know. 400. No, that wouldn't make sense because 1 is going to be like 100, and that's also wrong. Okay. Man, I'm trying to think about this because I'm essentially writing a web server from absolute first principles, from a web server from zero, and I have to think about like I've like defined basically an API that'll be functional and basic, where I can get a packet, I think the API will like auto retry maybe. But you know what? Yeah, let's keep it simple. Let's just handle our case first. So if it's 4, then go to line 200. We'll say handle pings, and then I'll say, and then line 120. Anything else, just go back to getting bytes. Rem get more rem more packets. More packets, sure, fine. Because I have to write rem. Okay, so and then on line 200, we're handling our ping. We actually don't need to get any more bytes, but we need to print some bytes. So we'll say, let's print. So we'll have the start of packet and the command. So I think we can just do this. We can just say print to device 1. Sure 1. Print to device 1. Sure 4. Is this how it works? Oh man. Okay, you know what? Hail Mary. Let's just see if it works. And we need to receive a byte too, don't we? So our program will send a ping, and then let's do sock dot. I don't even know how socket.receive works, man. Let's just look it up. Python sock.receive. Receive data, returns a buffer of bytes B. Yeah, okay. We can say response equals sock.receive, and we only need 256 bytes. Or let's just give it 1024. Let's give it a nice data number. Then honestly, print the response. We can parse it into a packet after this, but let's just do this. Okay, it's waiting for a response. Whether it's sending stuff. Illegal quantity error in 100. Okay, so all right, that means something at least. So, okay. List. In line 100, we get WC $. Then we assign WC to ASC WC $-1. I wonder what the error is. Okay. Here, let's. I guess let's close. Here, or here. WC $. -1. Do I have to like space it out or something? I doubt that's the issue. And you're waiting forever. Okay. Dialing. Getting a byte, illegal quantity. Okay. What is wrong with you, I wonder? Yeah, okay, let's just start with get #1. Let's just drop all of this first. We're gonna get a character from this and then print WC $, and then exit, I think is a command. If not, it'll just run illegal command and that'll solve it for us too. You know, they don't tell you this, but crashing is a valid way to stop a program. You can just let it crash. Like, that's totally fine. In fact, there's a whole beautiful I guess you can call it a paradigm out there. Um, what is it? It's fail fast, something like that. It's in Erlang, right? The whole thing just stops. The whole Erlang, the big idea of Erlang is you have a bunch of processes that are easy to stand up and tear down, highly used in like telecom and networking intensive applications. The Elixir language is built on the Erlang VM with what's the syntax error in 100? Why? List. Oh boy. Is it break? I guess basic doesn't work the way I thought it did. Failing fast is not working for me, is it? Okay. We're going to keep getting and see what happens eventually. Syntax error in 100. Why? Why? Okay. Commodore basic exit. Exit is a command. What did I say? Did I say escape? Escape. Oh god, no, it's exit. Run. To exit a do loop prematurely. How do I exit the program? Exit exp else $sign go to. Oh, it's stop. It's stop. Okay. Here we go. Bam, stop, go, run, boom. Should be the moment of truth. Let's see how it goes. Break in 100. Did not print WC. Okay. All right. Let's check it. Can't I just convert WC? WC equals, oh goodness, equals ASC WC $, print WC, run. Go again, Python program. Oh, I'm not on the right scene. It printed nothing, as you can see in the last run. Illegal quantity error. Why are you illegal quantity error? Dude. Pissing me off, man. Doing ASC is not working. Okay, let's check out ASC. Okay. The ASC keyword takes the first char of a string and maps to the numeric index of the Commodore ASCII table. It can be converted back using the chur. Evaluation of an empty string. Oh. Ah. That's the issue. I see. I see what's wrong. Okay. Get #1 WC $WC if WC equals nothing, then 20, and then let's say like 105, and I'm gonna respace all these lines anyway. But following this normal pattern that we have established up there, where we do the real processing, rather where we process it into the true like byte kind of quantities happening on the line below, that's perfectly acceptable to me. So 105 and then 110. If the next byte is 4, then go to line 200, and line 200 says print the character 1, print the character for 4, like return a ping, and then we're done. So let's run. Run it again, baby. Man, I need to like, ugh. Python has a REPL, but it's not as good. Type mismatch error in 100. Oh no. List 100 get WC $. If, oh, that's because I mistyped. Okay. Here's something. Is that if I was writing something with like syntax highlighting and like errors, like if there was a language server for Commodore Basic, it would have caught that for me. You know what I'm saying? Oh well, man. Oh, it's not printing anything. Right then. Okay, maybe we print some. Yeah, here. Maybe we start printing some diagnostics. Okay. Um, print byte is W. And then if it's, and then on 100, I want to say print packet run. Okay, do it again. So it's dialing. So we should eventually get byte is 1, byte is 2, byte is 0, 6565. Okay. Oh, I'm not sending a ping. I'm sending a data packet. That's why it's not pinging. Okay. Packet command dot ping. Wait. Is my schema wrong? Resend is 2. Ping is 4. Command dot ping. Am I not sending a ping? What? Wait. Command is command cmd len data. What? No way. Wait, hold on a second. Hold on a second. 2 bytes is just incrementing all the bytes. The header is the value of the command, the length, and the checksum, and the version. And it builds the checksum, and then sends it. What on earth? Why is this? Server states handshake. We're sending a command.ping. So it should be 1. Wait a second. Why is that? 142. Is it eating? Ooh, I have a theory that it's eating the 4. So let's list the program again. So if it's 1, then we go to 100. So we get characters until, well, we're not getting this. Oh, haha. That's because instead of going back to getting the next byte, we went back to getting packets in general. So now, oh man, I think this should do it. One two zero 6565. Okay, so it's not not working still. Oh man, this is gonna be like the worst stream to watch. Okay, so byte is this. If W equals 1, then go to line 100. And just keep repeating. Okay. So here, let's separate this out a bit. And let's say we'll put you on line like 103. Okay. Um, then 100. Go to 20. So, yeah, so we have that separated out. And low key, print space, quote, packet, quote, space colon, print packet I missed a space. Okay, and then let's drop this. So we'll say, okay, so we got a 1. We're getting a packet. And then we do this. We do the loop. Nope. We'll say get hash 1 comma wc $ space colon space. Get. Man. Why is the keyboard broken again, man? Why does it keep doing that? Get hash 1 comma wc $ 1 comma wc $ space colon space. If wc equals this, then yeah, keep looping. In fact, we don't need this here anymore because that's just an announcement. Or here, packet start is probably more accurate. Packet start, so we're going to print first. Okay. Okay. Somewhere along the way, it's like eating the packet. Packet start. Okay, and it goes straight back to printing 206565. So somewhere along the way, we don't actually manage it. Okay, so get this and loop until we get a byte. We'll translate the byte value. So print byte is WC. And I'll say P byte or C byte, command byte is 103. And then on the next line, we check if it's equal to 4, then go to line 200. And then on 200, we send some characters back. And then I guess the program low-key ends. Okay, let's see if we can get it. So we started the dial. And packet start and then a syntax error. Okay, that's something new, I guess. 105. It's because I didn't say to print anything. What is it? Question mark? Run. I think it's question mark. I think question mark is the shorthand for basic print, is what that meant there. Packet start C byte is 1. Okay, that's odd. That is real odd because I'm not sending a 1 now, am I? I'm sending a 1 and then a 4 and then a 2 and a 0 and 2 uppercase A's. But it's still getting me a 1. I wonder if it like, do I need to flush it first or something? Get a byte. If it's blank, then keep getting bytes. Command byte. I wonder. C byte is 1. Man, just a second ago, man, I opened the stream, started streaming, and like, okay, you guys saw it. It printed 1-0-4-2-0-6-5-6-5. It was on the screen. I know it was. I know I saw it. And now it's not showing it to me. And that's odd. So we get the value into a new variable. If WC is blank, then go to 103. And then 105. On line 103, We get the real value and print what it is. I mean, let's just run it again. Like, what on earth? Okay, we're dialing. Okay, getting some headers. Packet start. C byte is 1. Maybe I need to like. Maybe I need to like stop. Um, Maybe it's like discard the first byte, then 103. If it's blank, like, or or WC $ equals W $. Then do that. Maybe this check will work. I don't know. We're basically looping until we get a byte that's different from. Oh, till we get a byte that is different from the first one. C byte is 1. Yep, not working still. That is so weird, man. Oh man. This series is gonna take forever, dude, because I don't know why it's not working, man. WC equals the ASCII. Oh my gosh, because I never actually used WC. I was using W the whole time. Oh my gosh. Things I should have caught just immediately. Oh, dude. You're kidding me. Watch this. Oh, dude. There's no way. Oh, and it made it to line 100 this time because it knows that the command byte. Oh, man. Syntax error in 200. Okay. Let's see why. Does it require a comma? Maybe it needs some commas. Run again. Oh, dude, I think we've got it. I think this has got to be it, right? Dialing, dialing, dialing. C byte is 4, and it sent some bytes back. It sent us some bytes, man. It sent us some bytes. It printed it right here. Boom. Boom. Oh my goodness. Okay, wait. Let's see if we can explore these bytes a little bit more. Okay. How to print hex values from bytes in Python. All right. How to print hex values from B in Python, like from like a byte string. .hex. .hex. Boom. Boom. Oh man. Okay, let's print their response .hex. No way, dude. Oh. Okay. Run again. I think this is gonna be a ping, man. I think we got a ping working. No way. I'll show you guys. 2-0. Okay. Okay. That's not what I expected. Maybe it's because each time it opens it up here. Maybe it's because each time it opens it up. Okay. Maybe it needs to be just like a print. I do remember seeing this. Because I think that might just be the hex for like the number symbol 1. In fact, let's check it real quick while it's running. You know, we've seen this enough times. And it's sent 01. It sent 01. Okay, so what this tells us is that every single get is not every single print on the Commodore 64 is like print this entire thing as like a packet. So that means we need to make this into a string. So here, I think, because I'm willing to bet that print #1 like opens up a new, it like opens up a whole packet, sends the one, closes it, sends again. So every time we do sock.receive, it corresponds to one print in our program. So we have to be assembling whole strings, is my guess. Oh, maybe not. Okay. Okay, here, instead of 1 4, let's just see if we can get back a basic like ping, find. Okay. So 12 8 or 12 9 ring, yada yada, 12 9 something C byte, and it sent 50. Okay, so it's only getting it 1 byte at a time. So I'm wondering, yeah, if it's actually just like the Commodore 64 on the Python, and we have to be recving a bunch of bytes in a row. Here, let's read into that. Python sock.receive. Okay. We'll wait until at least 1 byte of data is available. It is not guaranteed, even if you set a buff size. It returns whatever is in the OS receive buffer up to your limit. Connect, send all. Total data.append. Okay, so maybe we need a little loop. TCP, yep. Okay, always check for blanks. Is a byte stream. You should use a delimited protocol. Prefixing messages with their length. Okay, yeah, we do that eventually. Okay. Not available, WASI. That's whatever. Socket server, it'll simplify. I don't think we want to simplify. I think we want to get all the messiness. A tuple interface. Socket.afcan. Get host name. If something. Rekva. Okay. Receive data from the socket. The return value is a bytes object representing the data received. The maximum of data received at once is specified in buff size. A returned empty bytes object indicates that the client has disconnected. See the Unix manual page for the meaning of the optional argument flag. It defaults to 0. Okay. Let's check out the flags. Flags. The flags argument. Set close on exec flag for the file descriptor here. Let's zoom in a bit, you guys. Okay. Don't wait. Enables a non-blocking operation. Queued error should be received from the socket error queue. Close on exec flag. Sure error stuff. Out of band data that would not be received in the normal data stream. Peak. Don't remove the data from the queue. Okay, trunk. Wait all. I think maybe we want wait all. Is that true? Until the full request is satisfied. So okay, so I guess we want to say here, let's go there. I think we want to receive, in this case, let's just try to receive a header, right? PING, that'll be the header. We'll make it up. And honestly, let's just print just the plain response. And then the flags. Okay. Wait all. Oh man, where are the flags? socket dot flag. Set some flags. HV socket. Man, where are the flags? Get name info. recv fds. Okay, flags default to 0. Indicates that the client has been disconnected. What? What? Receive data from the socket. I guess it's for if you have multiple sockets. Receive message, receive normal data, and ancillary data from the socket. Message flags address. Data is a bytes object. Oh man, what are you, dude? Message wait all. 1, 2, 3, 4, 5, 6, 7. I don't know. What is it? How do I do it? Oh man. Okay, let's just leave it blank and see. How do I just receive message? Oh, I don't know if it'll do it properly, but let's see. I think it might. Tuple has no attribute hex, but it printed 1 byte. Okay. Let's looky Google it. All right. Python socket dot receive only receives 1 byte. Okay. Fixed length. Okay, yeah. So let's start off with okay. So we'll say we send all of our bytes, and then we'll say packet oh goodness, packet equals a blank binary string, and then I'll say while true, or while len packet is less than 4, then we can say packet plus equals a response and then print it. So okay, let's run our program. So I guess we need a loop to receive, and just to check, you know what, let's watch it live just in case. Type error, can't concat tuple. Oh, because it's rec message. Oh dude, I'm so sloppy, guys. I'm so sorry. Okay, let's watch it for real this time. In fact, we can even zoom in a bit. Moment of truth. Drumroll, please. G. Oh man. All right, well I guess that's a letter in the packet. Tried to print Bing. Okay. Packet plus equals the response. And then at the end, and while we're building, let's print resp. Printf resp is going to be resp, and packet is going to be packet. Okay, so let's see if we can get some clues into what's going on our internals. Also, I just want to let's add a semicolon to the end here because I don't want to send any new line or anything like that characters. So we rang. We're sending our whatever now. Yep. Code is ready. Okay, wait. So okay, wait. Look at this. Look at this. Look at this. Boom. Look at that. Okay. PING. It breaks and then it prints ping. It prints G rather. So why is? Here's the question: why is it doing that? It's because it's printing resp, not packet. I'm stupid. Okay. Well, so okay, so here's the architecture of the program. Okay. So, and it might be worth going into an explainer scene for this. Um, it's sort of like a state machine. Okay. So we have a state here. All right. It's called listening for header. Okay. So what this does is right here is this is lines one. What is it? Lines. What's that? 1 or 10. It opens up. So here, let's even add that. Let's add that. Open network device. So you open the network device. Then we want to listen for a header. And then let's do like it loops back in on itself. Oops. Bing. So it'll loop forever if it didn't get header. And can I do like, wait a second, function F12? F12? Windows key F? Okay, boom. Oh, ain't that better? So much more. Oh man. One of my buddies, he told me about this browser that he uses where like it has everything on the side, the tabs, instead of the top. And he was like, oh, the thesis, I think it might have been like Arc or something like that. One of those like trendy browsers. But like the thesis is that like, oh, vertical real estate is much more expensive than horizontal real estate on a screen. That's so true, man. Like, why on earth is every browser, like a vertical friggin' all the tabs take up like a whole like what is it, like an eighth, a sixth of all of the vertical screen space? That's crazy. Anyways, that's better. So okay, so we if we didn't get the header, and honestly, give me some space or zoom out maybe. If we didn't get the header, then we keep listening for the header. Okay, we get the header, and then we just want to get the command byte, and we handle it differently based on the command, right? So get command byte. And honestly, wait, let's make this all blue because it's on the Commodore 64. Or wait, Commodore's purple. My bad. Purple. Okay, didn't get the header. We get the command. Get the command byte. Okay, and here I'll annotate this with, I'll tell you what, lines shall always be in white. Network device 10. Listen for the header and loop if you didn't get the header. That is lines 20 and 30. Yeah. 20 through 30. And then another loop to listen for the command byte. What's that? If W equals 1, then go to 100. Yeah, so if the packet starts, then go to 100. And honestly, yeah, let's do that. 100 through 100 through 105 is this process of getting the command byte. And you actually happen on line 40. So 2030, 100 through 105. And this is a loop-de-loop and pull, and your shoes are looking good. Pull and bam. We'll say didn't get header. Okay, cool. I mean, command. listen for really this should be didn't get version. Listening for version, because that's what the first byte of our packet is. That really means packet start. Then we get the type of command. So then next it should actually it should not branch. It should handle a special case first. It should say, if you get a ping, then send back a ping. So, all right, let's say, yep, we'll say command equals ping. If the command is ping, then we'll just keep it simple, stupid. And we'll say send back a ping, which is just a packet of 1,4. And in fact, let's edit it so it is actually that. On line 200, it should be print #1, comma, chur, oopsies, chur $1, chur $4. Let's see if that even works. Here, I'll run the receiving program. Let's go ahead and, oops. We should expect our ACK to be 2 bytes. And run that. Okay, and while that's running, oopsies, I'll keep working on this. Okay, send back a ping. And then, and okay, it looks like it's done. Already done. Yep, 0104, beautiful. Okay, so it can send, we can ACK. Oh man, guys, that makes me so happy. You don't understand. Oh, that's awesome. Send back a ping. And then go back to listening for packets. Okay, let's give it a nice loop D. Okay. And command equals ping. What does that happen on? That happens on line 110. So let's make a note of that. Man, I'd like to know. 110. I'd like to know. Okay, so I'm having to like make this diagram to figure out how my program works. Okay, if you programmed back in the day, and I know I have some Shorts viewers who were like OG Commodore 64 programmers. Shout out to you guys, by the way. Tell me, did you have to make like diagrams and like write out on paper and stuff like this to understand how your programs function? Because nowadays I feel like I can, I can include enough metadata within the code itself, right? I can name variables, I can name functions, I can add whole comments without having to think about that. Was that a thing for you guys? Could you do that? Like, could you just program straight through, no notes, or would you have to do something like this? Would you have to make a little flowchart to understand your program? Let me know in the comments. Yeah. Ooh, let me clip that shit. 114. Making a note of that. Let's do it on the document here. Clips. 1 minute, 1 hour, 14 something. Let's start at 113. Ask old C64 programmers if they had to take notes to write basic. Boom. That's engagement bait right there. Anyways, okay. This happens on line. Send a ping back happens on line 200. 200. And if it's not, and honestly, we can just do, yeah. Let's just add to the end of 200, the go to. Yeah, go 220. Go 220. And then go back to receiving mode. This is on line 200 as well. Okay, boom. Okay. Let's all right, I'm torn. I don't know if I want to, or if it'll be best to send a packet to handle different packets, or like what's it called? Will it be best to like build a packet object on the computer side, or will it be best to, what's it called? Receive another kind of packet. Like maybe we receive a data packet and print it out, or maybe we like do an intentional failure or something. I don't know. Um, yeah, let's hmm. Okay, so the data packet is going to require. So yeah, here let's just look at the versions. We have data, resend, act success, and ping. We have 4 types of packets. Okay, ping is like a very basic thing. Um, data is also very basic. Resend and act are both dependent on data, and quite frankly, ping is unnecessary. We could implement ping with a simple sending each other an ack, and that would work just as well. But I have 266 values in command. Surely I will never use them all, so I'm fine with sending a ping just as is. Okay. So yeah, let's move to implementing. Let's implement sending or interpreting packets from the Commodore 64 on the Python side. So okay, let's do it. And oh man, this is gonna kill me. Whew. Okay. Okay. The ack is not gonna be chur1 4. It's gonna be chur0. Let's see if we can send a 0. It's gonna kill me if it can't, because then I'm gonna have to implement the stupid like plus routine or that stupid shift routine. Ugh, on the send and receive side, that would be fine. That would be fine. But I would love to not have to. 1-0. Okay, we can receive zeros just fine. Crisis averted. Oh Jesus, guys. Okay. All right, let's here. Let's not make our commodore overheat, although it's gonna overheat. I don't know why I said that. Okay, protocol test.py. Let's keep working on it. All right, we need to build a packet. Okay, 2 bytes. Okay, let's say from bytes. Def from bytes. Self and sorry, I saw a bug. It was not a nice bug, so I had to kill it. Yep. Okay. So from bytes. And I think we can say at like class method, in which case it's like CLS. Oh man. Well, this is a good time to test my Python experience. We're just gonna run it and see how it goes. And say bytes. Byte packet. Or honestly, yeah, byte packet. And what we'll do is we'll say oh man, it would be cool to have multiple constructors, but I don't want to bother checking the CMD if it's actually bytes, so we'll just use a class method like this. So we'll say self dot version, and we self dot version equals byte packet at 0. Self dot command equals byte packet at 1. Okay, now if, or here, let's go ahead and match self.command on the various things, because if we look at our packets, only data is going to have a checksum and a length, because these both only pertain to data. These guys, 2, 3, and 4, are all just going to be 2 bytes long. So honestly, yeah, here, let's go back to, we don't even need to match. We can say if self.command is anything other than, and oh, here, we can convert it to our enum object here. Ooh, wait, byte packet dot int. Ugh. Int. Yeah, surely that works. Or maybe it's like byte. Is this a thing? Whatever. Int. Yeah, that works. That'll work. Python will let that fly. That might not be the most efficient way to do things, but guys, I don't care. It works as it does. Good enough is a bad mindset. I know. We're prototyping though. We're prototyping. Okay, forgive me for making my toy not as optimal as it could be. Maybe it would be fun to do a series making it optimal, but it'll be fine, guys. I'm not making production software. All right, self command doesn't equal command dot data. Then what we can do is say self dot length equals 0, and self dot checksum is also equal to 0. Or no, checksum's not a property. Checksum is calculated on the fly, isn't it? And packets are only self dot data. Okay, and then self dot data is just going to be a blank data and return. Oof, wait a minute. I forgot how that works. Okay, so packet. Oh, nothing. They're just opening a card. Sorry, I heard like a noise outside. Okay. If command doesn't equal data, then yeah, what we'll say, we don't need any of this actually. And in fact, we'll say, we'll get the version and say if version doesn't equal self.version, then raise exception IDK what version means. Int. Okay. F string. So if the version doesn't match, and then we'll get the command, and the constructor actually wants the command to be an int, so we can just get rid of that. And then we'll say data equals, yeah, here. We don't need the length. We'll just say make a new class with the command equals the command, and data is nothing. That's viable, right? Wait, packet. Oh, I'm sending data with this ping, but I shouldn't be. Here, let's see if we can send a ping no data. No, let's keep working on this, and then I can go back to it and troubleshoot. From bytes, class, and byte packet. Yeah, so if it doesn't equal data, then just return the class at the command. Else, then we can return class at command with the rest of the bytes. Boom. Bam, bam, boom. And we might, here, low-key, I'll say to do, consider adding more validation here. Because I'm thinking that we might want to check if a packet, right, like contains a length. But I think it might be best to just like make the raw packet, be able to examine it, and then have like a, like a validate packet method on the class. It hurts the functional program in me to have like an object with method instead of just like, a basic data class with some functions on the data, but whatever, man. Make the command with the byte packet. Yeah, low-key add more validation here. And we'll validate the data against the checksum and the length. rather. Or perhaps, hmm, perhaps the length check will come when we're actually getting. Yeah, the length check comes whenever we're getting it. So yeah, we'll just say byte packet, and we want from byte 2 to the rest. I think that's how that works. Oh, and low key will have to be data equals this. And oh, isn't it like 2 byte? What's the thing? Is it byte array? 2 bytes? I guess, man. I don't know. Um, tuple? You throw it into a tuple. Is that a thing? I don't know. Python. B equals a B string of hello. B to bang is LLO. That's exactly what I wanted. And then tuple on B to colon. All right, that's perfect. Okay. Protocol test. And actually, we realize we don't want it to be. Maybe it should be a builder pattern where, we get the version and then we build. Let's not overcomplicate it. What am I talking about? What am I doing bringing the gang of 4 to the Commodore 64? Like, hold on a second. Man, hold on, man. Okay. Oh, how do I exit full screen? Oh, I'm such a dunce, man. Oh, okay, well. Is it F10? What's the full screen key? F11? F9? Escape? Oh, dude. I think I can just Windows key F it again. Okay, yeah. Okay, wait. Gang of 4 design patterns. Yeah, 94, dude. Oh, that's way anachronistic to have a builder pattern. That'd be stupid of me, right? I'd be foolish to use 1994 design on a Commodore 64. That'd be dumb. All right, anyways. Here's this. We're writing Python. Sorry, I got distracted. And we want to lop off the header, actually, don't we? Because we'll rebuild the header as we go, in fact. Okay. Okay. Cool. Cool. Okay. Let's say we do this. We do, yeah, packet that's just command.ping, resp packet, packet B plus equals response, print packet b.hex, and then I want to say packet equals packet dot from, what is it? It's from bytes, from bytes, on, yeah, just packet B, and I want to print packet. It should be a ping. Get rid of that. Honestly, let's simplify this. Print f p bytes packet b. I don't know why I said p bytes. Hex is just going to be packet b dot hex. You know what? I'm so mad at myself for saying p bytes instead of just packet b. I didn't save any characters. Packet b. Okay. And then f, oopsies, packet. Bang, 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 break. Here, what if we do this? No, whatever. I was thinking about, oops. I was thinking about making it like check if the ping was a response and then doing a test program where the Commodore 64 like sends a not ping and then on the next time around it would send a ping. I don't care that much though. I'm just gonna trust that it works. That's bad practice as well. Oops. Cannot access local variable packet where it's not assigned. Okay, that's useful. Let's say while len packet b packet %s packet b packet underscore bytes slash G. Okay. Let's just oh dang it, dude. Oh, protocol test. Now so let's check. Packet makes it from the packet bytes and then it prints out the packet. Okay. Python protocol test. And let's run our Commodore program. Okay. Okay. We're building up a packet and we're sending it. Oh, something tells me I messed something up again. Resp packet, when really it should be packet bytes. And honestly, we don't really need this one anymore. Because, or actually, to be honest, I want to see what's going on. If it's, I want to see the responses as they come in. I want to see the like PING or 1.4 kind of thing, but I don't really care about self is not defined. Oh, it's class, not self. Okay. Self.version. Next. F class. Let's see if I use self anywhere else in this. Self.command. If command, just plain command, doesn't equal command dot data, command. I have to convert it to a command first, don't I? And here, let's do a quick test. Python from enum import enum class foo enum bar equals 1 baz equals 2. And then shoot, what do we want to do? Yeah, I wanted to check if foo at 1 should outprint foo.bar. Okay. Let's say BBR equals foo.bar print BBR. Okay. I want to know what foo at BBR does. Okay, cool. We can do stuff like that. Protocol test. All right, so let's convert it into a command. CMD. All right, command, it gets an int and it converts it into a command. Insta, and it'll send that command back. Yeah, so if the command is not a data command, then we can just return the class with command. Otherwise, I will make the packet into the thing or whatever. Beautiful. Okay. Dial again. Oof, that's not that. Protocol test. Dial again. Oof, I'm not showing the Commodore screen. That's an idiot. Exception. IDK what version 1 means. It is version 1. Oh, do I have to make it into an int? I have to make it to an int, don't I? Okay. All right. Blah, 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 blah. It's little, but you'll deal. Oh, int. If it doesn't equal... Oh, that's because version is a byte string. Oh my gosh. We don't have to convert the version to an int. It's just a raw byte. Oh well, dude. Oh my gosh, this is killing me. So many little quirks that you don't think of, I guess, when you're doing certain languages. But it is failing in this. Man, it's sending IDK what version means, IDK what version 1 means. And it should be hex 1, man. Okay. Let's just print version, print type the version, print type a class.version, print class.version equals version. Okay, that should diagnose it at least. So let's get our ping back up and running. Dialing. Okay, it's commodore's receiving data. All right. Okay, so something is converted into an int. Something is an int, something is a byte. The first one's an int, second one's a byte. So from bytes, version is an int. Okay, which means that actually I think what we can do is make version into an int. Am I crazy? Am I crazy to say that a byte string indexed at a particular place is just an int? Can I do this? Am I insane for that? Tell me. Unsupported operand types for int and int bytes. Okay. Let's okay. So 2 bytes is wrong now because we converted the version to bytes. Oh, dude. Okay. Man. Nothing ever goes my way. Header equals blank binary string plus equals that. Maybe. Maybe, I don't know. Or wait. Instead of plus equals self.version, we can just start it off as a bytes array of, one length. All right. Oops. Oh, well. Whatever, dude. I don't care. Okay. I think this is the one. I thought it's the one every single time. That never changes. I always think it's the one. Okay, it's not the one. But it's correct. It's correct. 0 is not a valid command. And if we look at our Commodore 64 program, and here, let me show you in more detail. Value error. 0 is not a valid command, right? So we tried to make a packet out of the data we sent back. And if we list the data we sent back, you can see we printed 1 and printed 0. 1, 0, right? 0, look at our packet protocol. Do you see a 0 right here? I don't. Boom. Okay. So, all right, I'll call that adequately tested. Run it again. Okay, so it was a failure, but only spiritually, it was a success, if you think about it. All right. Let's go. Okay. Boom. Boom. We're making packets from bytes. Boom. Okay. Let's keep going. Let's do a data packet. Let's send and receive a successful data packet with an ACK. Yeah. Let's do it. What time is it? Hour 38? Yeah, we got this. Okay. Because we know how it works now. And sorry, I gotta make it smaller. All right. Okay, let's limit our scope a little bit. Let's send a data packet and receive an ACK. And that's it. That'll be all we finish. Okay. So all right. So we'll start off with the handshake. And if packet doesn't equal ping, or rather if packet equals ping, right? So they should be equivalent. Then state should be web server states dot web server states dot. Oh, I need to make the next one. I guess open or whatever. Like, we'll give it an API. I don't know, man. It'll all be kind of bespoke once we get to it. Like, yeah. Web server states, sending data, maybe idle. I don't know. I'm trying to think of the API that we want to use this from Python, right? Like what? Okay, what if eventually I need to take this code, this while loop, and make it into a class that's actually like an async thing, because I've learned how to do async recently. And I could theoretically see this working as like an async loop. I guess web servers are, by nature, async friendly, or like that's like an async friendly problem space for sure. So we could make it async eventually, but for now let's just make it blocking. Okay, so we start off in handshake. So once we've completed the handshake, so once we've pinged, let's send data. Yeah, let's say send data, and let's make that a state. Send data, and this will change eventually because I am thinking already now that we have two functions, I already want to break this out into a class. I'm going to resist that for now, but whatever. If elif state equals web server states dot send data, let's build up a packet that says, yeah, we're just going to say data sent equals a packet. It's going to be a data packet, and it's going to say hello from Python. And then, yeah, hello from Python. And then, okay, here's also where we want to start thinking about a dedicated ASCII to PETSCII converter, because let's look at the PETSCII table. Can I press X? Oh, beautiful. PETSCII, okay, the PETSCII table, right? There's no ASCII for set text color, right? This is Commodore 64 PETSCII stuff. There's no ASCII for any of this. It's all PETSCII stuff. And in fact, the ASCII table contains things for lowercase letters that, in fact, the Commodore 64 does not have. The PETSCII table contains things for these little symbols, right? All the codes map to a symbol, but the PETSCII ASCII doesn't have all these symbols. And I guess we do have actually lowercase symbols, but it's actually a whole separate mode of running the computer, believe it or not. It's not just, it's not as simple as uppercase and lowercase. It's actually everything becomes lowercase or like symbol mode or whatever. So let's just say hello from Python, all caps. I don't remember. Do I convert it to uppercase here? No, I don't, but that's honestly fine, dude. I don't care right now. We're building as we go. So send data, not send date. elif state will send data. We want to make a data send. And I want to send all data sent dot 2 bytes. And okay, our Commodore 64 program. And honestly, here, let's break this out into a separate command or to a separate function. I'll say def receive bytes. Let's do like length. Or here, we'll really want socket length. Yeah, I guess socket and length is all we really need. We can worry about the rest later. We'll say while, or say bytes, p bytes, packet bytes. I keep doing this to myself, don't I? Equals this, and while packet bytes is less than the length that we pass in, receive equals socket dot receive, and we'll just give it a constant buffer of 1024. That's overkill, way overkill, but that's what's in all the Python examples. Whatever, who cares? And then I'll say packet bytes plus equals what we received, and then return packet bytes. Otherwise, it'll infinitely loop. it might be wise to add a timeout function, but who cares, dude? Here, p bytes equals receive bytes on sock with a length of 2. Okay. Yeah, we want to receive bytes. We might even it might even be prudent to do packet dot receive packets, like a nice class method on the function that returns a packet of whatever it receives. That could be good. That could be good. Instead of from bytes, we could have that method that dispatches on receiving on the level of receiving the packet, right? We don't even interact with the bytes. I don't think that's maybe not good to couple it that tightly. Who cares? We can refactor. You can infinitely refactor any program, right? Okay, so we send bytes, and then yeah, we want to receive an ACK, received ACK, and that should equal packet, or no, it should be receive bytes with sock length 2. Print received ACK. Hello from Python. Here's some more. And ooh, really, we're gonna have to calculate a checksum on the Counter64 end. Won't be a big deal, but we'll still have to do it. Yeah. So, yep, we'll send all, receive an ACK, print the received ACK, and honestly, we'll print data sent while we're in here. And then after that's all said and done, I want to break out of the loop. So, okay, let's go to our program architecture diagram. And, okay, so that's command ping. Listen for the version, get the command byte. Okay, so if we get the command equals data, and let's get purple, and that's going to be command is data. So if we're on if we're looking at a data command, then what we want to do is we really want to get a couple fields. We want to get, what is it? Checksum and then length. Get checksum, get length. So let's write that. Okay. Let's list. And in fact, what we want to do is command equals data. We want to give that its own happy path. And we'll say, we'll actually make this go back line. We'll put that at 190. And we'll have to remark that on our thing here. Send back a ping. And then go back, or if it's not, get checksum, handle it, and then go back. Didn't get a command, then we'll loop. And here, let's speak, for the sake of completeness, we'll add this line back here. And just note that we want to get rid of it eventually. Just keep that note in your head. This is line 190. 190. Oh, my phone died. Oopsie. Invalid command. So that's really what that means. Or unsupported command, maybe. Whatever. Invalid command. That's good enough. That happens on line 190. So command equals data. This check happens on, it'll happen on line just 120, won't it? Right after 110. Okay. And honestly, let's like make these things closer. Let's put all these guys inside. Yeah, it's fine. You guys can be under, but you need to be inside as to not be confused with neighboring lines. Didn't get version. line 200. Let's bring it back over. Can I like add another handle? Oh well. Line 200. And it'll say, yeah, honestly, you don't even need one. It's just doing that. Okay, so get checksum, get length. And then I guess it'll get data depending on the checksum. So, but let's walk before we, what am I saying? Let's walk and then we'll run. Okay, line 120, it's gonna be if the wire command is equal to data, what is data? Data is 1, I believe. Yep, if the command is data, then honestly, let's go to 210. We can put it at 210. Or yeah, let's put it at 210. That'll be the receive data, routine. And then if it's not, then really we can just let it overflow. Yeah, we need to keep checking. So we'll say handle data. And at line 210, let's start building our data routine. So for starters, we want to say W. So we'll say get hash 1 W length $, and if W length $, if it's blank, then 210. Then keep looping forever. So if it's not blank, then we can immediately go next to, sorry, I went into quote mode on accident. 1 WS, the wire sum, and if the wire sum is equal to blank, then 210 or 220. So we get the length, we get the checksum. So at this point in time, we will have gotten our entire header. And once we get the checksum and get the length, and really this should be switched, get length, get checksum. And let me make our circle a little bigger so it can fit just enough of that text. Okay. And this happens from lines, oopsie, text, stroke white, to, oops, nope, I have to do it outside the text box. What is that? Lines 210 and 220. 210 and 220. Once we've gotten our length and our checksum, we can get the data block and we want to get the data block and what's it called? And check its checksum. So, all right, let's say get data block and build checksum and check it. That it'll be all one fell swoop, because what we can say in here, let's bump this up to 230, because line 230, we're going to say WL, the length, should be equal to the ASCII value of W length, of course, -1, and WC should be equal to the ASCII value of WS should be equal to the ASCII value of the wire sum, -1, of course. Now, we can say on line 240, for, and we can say CS equals 0. Init checksum 250 for I equals 0 to, we want 0 to length, to wire length, and 260. We'll say, and ooh, we want our data payload, don't we? Can you add to strings in BASIC? Oh, I feel stupid for having asked that, but let's, and I haven't been showing any on my screen. Oh, I've been narrating pretty well though, so you should be fine. Can you add strings, or how to concat basic strings? Commodore 64. String manipulation. Define strings, concatenate. Yeah, okay. So I can just concat with a plus sign. Beautiful. Okay. And we'll also low-key say backspace, backspace. We want wire data $sign to be equal, oopsies, equal to a blank string. Or really, in my opinion, it should be the data is equal to the blank, and then we'll have a wire data which corresponds to our packets. Because remember, we have to run a little loop for every single byte that we receive. Right? We can't just for I equals 0 to WL, we have to go until we're done. And in fact, man, it might be worthwhile to make this a while loop. See what I did there? But low-key, I like this way better. I'll say we'll receive some wire data. Or no. Get #1, put it into wire data. If wire data is nothing, then keep looping. If it's something, then data should equal data. Oh goodness, where's the plus sign? Oh, I'm so stupid. Oh, there it is. What is it? Okay. Get that muscle memory down. All right, data equals the wired data plus the wired data. We just slam it on there. Oh, and actually, no. It should be the character. Oh man, what should data be? Yeah, data should be a string, and we can manipulate the bytes if we need them. But for the most part, we're going to be handling textual data with this program, so I'm not going to bother with any other, conversion nonsense. So we'll make a chur out of the ASCII of the wire data. -1. So we'll do that, and then 280 next. And here, I'll say rem get whole packet. Oh, and honestly, you know what? Honestly, here, before we even do this, let's make a wire data number here. Wire data equals ASC WD $-1, and clear the line. Yep. And then 280, line 280, we want to do the checksum. We want to build up our checksum. It's going to be checksum XORed. Oh, how do you even XOR on Commodore 64? I know in Python it's the, up caret operator. Commodore, I already have this guy open. ASC, is there a thing? Basic functions? Basic function empty. Search up XOR. XOR with previous basic token, basic keyword abbreviation. Hello world. Basic 2.0. You know, I don't see an XOR, do I? No abbreviation, no abbreviation. Yep, that makes sense. I'm not learning all these abbreviations, by the way. It's going to be long programs. Okay. Yeah, what is it? Is it up caret? Like, is that? I don't even know where up caret is. XOR on this wiki. Moondust, basic token, basic keyword abbreviation. Here. Why don't we go to the definition of a function? Because I know that when you're defining a function, you can only use numeric expressions, and it gives us a complete list of numeric instructions somewhere on here. Let's see. Return address, evaluate single term, evaluate in direct mode, use of a function in a program, related release commands. I think we have to go to def here. Aha, def, fn function name, FRE, and or. Oh my gosh, is there no XOR in Commodore 64? There's no way. Wait. Oh gosh, wait a second. 6502 XOR. Instruction set. It can't XOR the accumulator with itself. Is there an XOR on here? Deckerman, ASL, or a. Oh man, is there? Oh, gosh, XOR, please. Okay, signed values. That's the only case of it. In 2's complement representation, we simply flip. Yeah. Wait, but how do I XOR on Commodore 64? No way. Wait, do we have to make a new checksum method? How to XOR on Commodore 64? EOR? Yeah, bitwise XOR. So we need A and not B, or not A and B. Okay. That's fine. Okay. Okay. So, all right. CS. It's gonna just XOR it with itself. So CS and not WD, or not CS and WD. Yep. Okay. That should work. So, all right. So we've built up. Sorry, I typed out the formula there. CS equals CS and not WD. And honestly, man, I got a rem XOR. Okay. 290. So we got the data. We got the wire data. We built up our checksum. We went to add our output data. Should just be $$ on WD. And then 300 next. So that should get every byte in the packet, shouldn't it? Yeah. And let's say 310, let's just print, let's say all we're doing is printing out the data. Okay. That should work, I think, right? Here, wait. 210 to 230 is getting the length, getting the checksum, and then it moves straight on to building it out. Print D. Here, wait. Let's do some more comprehensive print diagnostics just for the moment. So 310 print. We'll say start off with, what do we want? We want checksum is going to be WS 320 print. What do we want? We want to print the checksum, then WS, then we want to print length, couple spaces, wire length. Yep. 330 print wire data. Oh, beautiful. D $. 340 print calced, and this is the calculated checksum. Should be CS. Okay, here, let's annotate the code on our little diagram here, and we'll say it's actually lines. We get the data block and build the checksum, and we don't check it just yet. Checking comes next. Yeah, in fact, what I'll want to eventually do, I'm thinking, is build out an API that has like a function send packet, and it automatically retries stuff for me. It'll automatically handle the ACK. It'll just give me, I can just pass strings back and forth. That's the eventual goal. I don't want to have to worry about the implementation detail. I just want a simple API, send a string, return a string. That's it. That's all I want to do. Oh yeah, so get data block and build the checksum. That's lines 240 through 300. 240 to 300. Boom, move it in. And honestly, group selection. Now we can, move it all about. Group selection. Okay. Here we can adjust those lines there. Okay, so here's our program architecture so far. Let's run it and see what happens. Oh, our Python program expects to receive an ACK. Okay. Let's just send an ACK. Print print 1 print I don't know. What's an ACK? It's 3. And then 360 go to what do we want to receive? Okay. Rem send ACK. I think eventually what we want to do is break out a lot of these into their own subroutines and do Go subs. But for now, we'll do this fine. So, okay. Python protocol test. And I'm hoping of course there's an error in, oh goodness. While packet bytes. Okay. While the length of the packet bytes is less than length. Okay, so, and actually it looks like it sent the whole ping routine, which brings me joy. So let's run it again. Okay, here, let me zoom in for you. Okay, so it failed. IDK, what version? 13 means. It sent back a 13. Somehow. Perhaps our go-tos are wrong. Because we printed class int, and false. Oh, there's a new line. There's a new line there, isn't there? List. Why are we printing a new line? And in fact, that's wrong. We want to get... I wonder, wait, what's that from? Okay, you know what, here, I need... I need some more descriptive print statements to tell me where I am. Quite frankly, I'd love a debugger right now. I can put a breakpoint and go, but we don't have that. Okay, print. Sending data 1. Print received ACK. Print sending data 2. Print pinging / doing handshake. And then up here, I want to get rid of all these prints because we don't need any of these anymore, do we? D3K. Receive bytes. We want to ignore that. Loki, we want to drop packets, drop bytes until we receive a 1, don't we? Here, let's just run the program again and just see. We have better viz now, so we should be able to see where we are better. Okay, doing handshake. It sent that packet across. And it did its thing. It received a packet. Oh, and then it said pinging doing handshake again. That's weird. You shouldn't do that. That's not what should happen. Okay. Pinging doing handshake. Oh, there's no equals method. So it's infinite ping. Okay. Oops. List. Is my ping response, is it accurate? Aha. I think there's a residual new line right there. Let's get rid of it. And low-key, I think infinite pings is a reasonable program. Is that crazy of me? A program that just infinitely pings back and forth? I guess that's a DDoS. Or no, the ping program. It just pings until you say stop, doesn't it? Yeah. Boom. That is ping running on a Commodore 64. Every single time you see packet start, it's receiving a new ping packet, and it's already sent a ping packet back. Boom. No way. Okay, perfect. That's beautiful. Here, I want to check something real quick. I want to say byte string A is going to be ABAB, B is going to be BABA, and C is going to be ABAB. Is A equal to B? No. Is A equal to C? Yes. Okay. So that means we can, we've got some hashable stuff going on here. So we can define an equals method on our self. I think there's a better way to do this or something. I think I can do a comparison or something, and it'll give me ordering and all this. But whatever, dude. We're gonna just return a self other is the tuple of self dot command cmd and self dot data equal to other dot command other dot data. Just as reasonable to do, and actually is instance other packet and this. I think this is like valid Python. It'll yell at me if it's not. So it should start off and do the handshake. Oh, guys, I'm so happy that the infinite ping worked, by the way. But anyways, it should do one handshake. Okay. So it was able to do that. Syntax error in line 240. Let's check out line 240, shall we? Line 240. Aha. No remark. Oh, I think CS equals yeah, that's fine. Rem. Boom. Okay. Yeah. Okay. So what happened is I didn't have a remark statement. Command 64, in order to make a comment, you have to type rem. Or otherwise it'll fail. Command byte is 1. That's data. Did I handle data? Wait. um, let's hold on a second. Oh, I pressed end and it worked. Did it? Wire data is nothing but calc to 76. Okay. Okay, you know what? That's a start. That's a start. It sent that the C byte is 64. Here, you know what? Let's do this. Oh, um, no. Okay. Print data sent dot 2 bytes dot hex. Looky, let's plop that down there too. Okay, I just want I want the hex values of what we send over, because it should be, what should it be? It should be one. It should be one checksum length. Yeah, hello from Python. And let's also print lang f string length of message is going to be lang len b, oh no, packet, or rather data sent dot data, right? Length of message bar message data sent dot data. Go again, buddy. Never closed. Will do it, won't it? I'm used to auto closing parentheses. Don't be mad at me. Run. Okay. Also, why'd the program exit? I guess I didn't have the right go to or whatever. C byte is 1. Okay. That's not right. um, the data it sends should not be, you know, zero. It should be 0, 1. It should be 0, 1. Break into 60. So here we can see that. Break into, what's 260? 260 is getting the wire data. Okay. So, okay. Invim protocol test. So we sent 2 bytes. Why is 2? Why are you turning into 02? You should be 01, man. 2 bytes. Header starts off with the version. Version byte packet 0. Ah. Ah. No, that's not the problem. Wait, no. We're not doing from bytes. We're doing 2 bytes. Header starts off with the self.version. When we init, make self.version this. Okay, wait. From bytes. No, wait. Data tuple. It's frustrating. Okay. More diagnostics? Okay, wait. What was the output of the last process? The length of message is 17. We got the message was hello from Python. Here, what if we say after we get WL and WS on line 235, let's print the wire length is WL space W sum WC or WS. Is that right? WS. Okay. We have some more diagnostics now. We can check out what's going on. Okay. Streaming for 2 hours 20. Pretty good. And I'm kind of locked in. Oh, and my laptop died too. Oh, guys, this is not good. Okay, the WL is 17. The WS is 64. Okay, so it's doing it right. It's sending it correctly. But for some reason, the Python program is being all wonky on me. Okay. Sending data 1. Length of message is 17. And the message was hello from Python. And the commodore 64 sees that. It acknowledges that. What if we do some diagnostics within our for loop? Let's add in I equals 0 to WL 255. We'll say print I, and then a space, and then WD. Or no, W or D $, and then just print the data we have. Ooh, that's an issue. 290 should be, goodness, backspace, 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 D $, plus the character built from WD. And let's go ahead and init our D $, up here too. CS equals 0, D $, D $, oh man, equals, quote, quote, shift backspace, oh man. Oh, it's broken again. No, it's not. I'm a fool. Wait, yeah, it is. Because I'm in quote mode? Yeah, okay, I was in quote mode. I didn't break it. Okay. Rem, init outs, checksum, and data. Let's just keep it simple. Okay. Run it again. Okay, let's get more bytes. Do the ping. Hello, hello from Python. Ooh. No way. No way, no way, no way, no way, no way. No way. No way, no way, no way, no way, no way. No freaking way, dude. Hold on. Okay, so we get through the whole message. Hello from Python. And then we get down here. I don't remember if I printed the checksum. No way. Oh, that's awesome. That's incredible. Oh, man, I'm so wait. Honestly, man, run that again. Run that again. I just want to see it again. Checksum length wire data calc. Okay, so we're not printing our diagnostics there. Am I doing a for loop wrong? Does there need to be a break section? Let's look it up. Commodore 64 for loops. And let me open up my other laptop again. Print next I. Does there need to be a break? For the innermost loop, yep, okay. Loop termination, the loop until the counter variable exceeds the target value. Oh, so it's 0 through 16, isn't it? So it needs to be through length minus 1, perhaps? Through WL minus 1. Oh, no. Minus 1. Okay. I'm willing to try this. Stop. Run the listener program. Dial in. that says ring, by the way, I think. And package site, hello from Python. Oh my gosh. No way. Look at that. Guys, look at that. Look at that. No, look at that. Checksum, and we calculated the correct checksum. Oh my gosh. Oh my gosh, it worked. There's no. Oh my gosh, it just works. Wow. Wow, 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 wow. Okay, I'll tell you what. It looks like we have a bug in our. Shoot. In our program, in our function that receives bytes. It looks like we have a bug. So let's go ahead and print what we receive. F full is going to be receive rec v, and then hex is going to be rec v hex, and that'll be useful for us to see. Okay. Now let's run our program again, and you know what? Just to be sure, let's list it first. So it prints all that stuff out, and then it prints. It sends a data. It sends an ACK back, right? It sends the version 1, and it sends the ACK command. So all right, run, and that's not run. Python protocol test. Zoom in. Let's see it work. Do your magic, programs. Oh man. Oh, sending data 2. Sending data 2. Okay, and it stopped because the commodore program doesn't know to go back to the beginning. So I haven't implemented that feature yet. Oh my gosh, guys, I think I low-key did it. I think it works. No way. Oh, that's incredible. Oh, that's incredible. That's awesome. Okay, I'll tell you what. Let's do this. Let's say, yeah, let's say 360, 350. Instead of sending back an ACK, let's say if the calculated checksum is not equal. Okay, no, we know it works, so low-key, let's just. If the calculated checksum equals the wire checksum, then oh, I don't want to organize this right now. Oh, basic, you're killing me. Okay, if the checksum equals the wire checksum, then I want to just exit. Okay, then oh, you know what? No, just send the ACK. Just send the ACK. No, oh, we said we would calculate. We said we would send data and send an ACK, and that the ACK can only happen if it's oh, if it's working. Okay, here, wait, what's our diagram look like? Send back a ping. Okay, get data block and build checksum. And this is, what is this? This is lines. What is that? 250 through, and let's just say 340. 250 through 340. And what is 240? Just because I don't have it marked. Oh, that initializes the data, and yeah, let's include that there. Okay, so, and I don't know if I'm on the explain scene, and I just pressed a mute button. Okay, so I have this program running in the background, this guy, my OBS management scene. You can see it's like toggling all my screens and stuff. I have this thing, toggle mute. Doesn't work because I have a new audio setup, but whatever. Okay, so get data block and build checksum. Oh, I already tried to include that. Group selection. Oh, nothing is grouped. Select both. Group selection. And go ahead and attach. Boom. Okay, cool. So if huh, I guess the smart thing to do would be to have a whole state machine on our Commodore 64 web server that retries multiple times. I don't know if I want to implement that yet. Like if it'll like retry a couple times, and then it'll crash the program if it doesn't properly receive the byte or whatever. Okay, let's just get length, get checksum, get data, block, and build checksum. Um, okay. Now it should. Let's go back down here. Bang, bang, bang. And then let's just do the happy path first, right? Go over here. Become purple. I don't know why I did this in purple, because the idea was like, the idea was that in this diagram over here, the C64 is not even purple, it's pink. Oh, it's pink. Whatever. I like purple. I'm using purple. It's my favorite color. That's great. Okay. Get data, and then we'll go to over here. Oops. Send back an ACK. And that'll be line, I don't know, 500. If checksum equals, oh, if CS equals, goodness, the wire checksum, right? The calculated sum equals the wire sum. Then go to 500. I don't know. I'll map this out. I'll tell you what. Next stream we'll map it out. Like I think I'm gonna end up with like maybe a spreadsheet or a text document, or it'll just be in here somewhere where I'll have like subroutine send ping line whatever, subroutine send ACK line whatever, subroutine send da, da, da. Like I'll have like blocks written out as well as the flowchart going at all times, and that'll be a nightmare to bookkeep, but ah, you know what I'm saying? Okay, this is actually, that's line 350. Is if the checksum's correct, and we can even say checksum match. Okay, if the checksum matches, send back an ACK. And that's line 500, so we'll say 500. Yeah, 500 is just this, print the device one, bada bing, bada boom, send back beautiful 2-byte string, send ACK, rem ACK, and then otherwise, and then 510. Where do we send init checksum data? Get, where's the print? Oh, is it already? Oh man, I'm already list everything before line 200. Yep. Okay. 510. Go to 20. Yeah, go all the way back, I guess. Okay. So send an ACK is 500. Oopsies. Send an ACK is line 500. That's 599. 500. And then going back here, take it underneath. Low-key arrow type, I want it to have multiple... Ooh, no, that's not what I want. Multiple squiggles. And lock it out. Make a line, make a note. That's line 510. And yeah, let me zoom out for a second. Just look at our program flow here. This is a web server, guys. This is what a web server looks like under the hood. Let me correct myself. This is what a really bad web server looks like under the hood. A web server that can only receive basic packets that might suck, and a web server that it can only print stuff. It doesn't. You can't do anything with a web server yet. Okay, let's run it. Let's go to our main scene. Okay. Oh no, I don't want to edit it. Plus plus. Let's run it again. The program should do a handshake, send one packet of data, print it on the Commodore 64, ACK, received ACK, sending data to, and then it exits, and then it's done, and then it's done. Yes! Oh my gosh, yes. Oh, that's awesome. Wait. Wire data, here's some more. Correctly calculated checksum. Oh, that's pretty. Oh my gosh, that's awesome. Yes, dude. Oh, yeah. No way. Man, all right. You know what? You know what? We're ending on that moment. We're ending on that moment right there. Wait, before we end on that, let's look up something real quick. That's not that. Okay, how to save basic program on Mr. Commodore 64. I think there's a way to do it. Let's say I write a program on the Mr. What are my options? Is it good old school to bind save a tape, or perhaps wait through the I/O board? The tape player I have doesn't record. Put it recording directly to my computer. Blank disk images here. Okay. Mr. OSD, create a blank disk. Okay. Hardware. Parallel disk drives, if mounted, always never. Yeah, if mounted, parallel port enabled. Erm. Oh, here's an idea. Here's an idea. Idea for next stream. We write a program that sends a program back over the wire. Like it'll not quite a quine, but it'll print itself. Wait. Can you print a basic program as text on Commodore 64? List. Output into other devices. Oh, you can output to other devices using command redirection. I could totally do that, couldn't I? Okay. That's for next time. Okay, let's mount a blank disk image, shall we? Hardware, or no, mount on number 8. I guess an empty D64, empty D64 disk image. Mr. Okay, it says here's some empty D64s. Oh, oops. Code. A game for the Commodore 64 based on nuclear reaction. Oh, what? What? Code drop? What? Is this blank disk images here? Core select, tier DOS, save file name. Okay, I do not have permission to get the files, but okay. I'll tell you what. Give me a second. I'm gonna make a copy of the blank disk on my Mac. So here, let me get Finder up. or like files or whatever. Because the Mister is a network-enabled device. Mister. Do mounted drives automatically save their contents on Mister if you save? Keeps save data in volatile RAM. Commodore 64. And you know what? I'm just gonna use Gemini to just save it. Wait, the save signal on-screen display after performing your in-game save. Opening the OSD, swap joystick, reset and detach cartridge. Exit. And here I'm gonna tell you what, for security's sake, let's just list through 200 and then list everything after 200. So I have it preserved on video if I need it, but I'm gonna try my best to save this actually. So, okay, here. Gemini.google.com. I have a Mister that I'm using the Commodore 64 core. Please tell me how to save a basic program I wrote to an empty.d64 file and make sure it persists across sections. Across sessions. Stop it. Persists across sessions. In other words, I want to be able to save my program to a file called empty.d64, copy it to a new file, reset the Mister, and load the program from the copied D64 image. Okay. I'm new to the Commodore 64, so I'm giving myself some slack to be able to use AI on some of this stuff. Is that an option? What? No way. Upter. No, it's not an option. You're stupid. Okay. SD card. Sorry, I'm on the computer on my Mac. I would do it on my main computer, but I don't want to figure that out right now. Should be in games, I believe. And it should be in a file called C64. Yep, okay. Copy empty.d64 to paste item, copy, oh gosh, rename you to web server.d64. Okay, let's exit. Check it out again, because now it should appear, right? You saw that on the screen. And here it is, web server.d64. Okay, write and save your program. So let's say save, oopsies, web server on disk 8. Saving web server. Okay, so now let's list. Okay, here's the moment of truth. List $sign from 8, or load $sign from 8. Searching for $sign. Loading. Ready. List. Web server. Ooh. Ooh, I think it worked. I think it worked. Okay. All right. Okay, wait. Save my prog. Permanently save to empty T64. So I think I can open up this, mount a new image, and let's do load $sign from disk 8. Okay, and it's empty. Now, moment of truth. Can I reload my web server? Load $sign from disk 8. List. Web server. Ooh, load web server from disk 8. Searching for web server. Loading. List. All right, I think we're saving programs, guys. I think we're saving. And just to be double cautious, copy web server.d64 and paste it over here. Rename it to web server v1, web server version 1.d64. Web server here. I'll say web server.v1.d64. Let's go ahead and mount web server v1 d64. Load $sign disk 8. Give me list. Boom, it works. Here, wait, load web server from disk 8. Just double checking, guys. I'm terrified, 'cause, man, every single session, you've seen it, I've had to retype the same program every single time, and the program's getting to the point where I have to save it. I can no longer, waste, I don't know, minutes, close to an hour of every session doing this. And okay, it just worked. Okay, that's beautiful. Our web server, our very basic web server, is starting to shape up. Super happy with where we're at. And in fact, I think I want to move towards building out the basics of a ping, or not a ping, the basics of this whole keyboard injection thing, or not the basics of the keyboard injection thing, but rather the basics of the writing a program thing. Yeah. So, alrighty. And you know what? Here, let me check something real quick. Load web server from disk 8. Can I do it on one line? Loading. Ready. No, I can't. Or maybe it is working. No, it's not working. Okay. Anyways, I wanted to run from whatever. I'm looking ahead to the future when the goal is we're going to be able to send a whole program over the wire, execute it, and then return to the web server program at the end. Wouldn't that be awesome? Anyways, 10 print. Thanks for watching. 20 go to 10. Run. That's going to be it from me for now. I'm super happy with how far we managed to get today. I'm genuinely, I can't tell you how stoked I feel right now. Just how stoked I feel that we've made this program. We've made a basic web server. We defined a communication protocol. We're turning raw bytes into dataful packets. To me, that's basically a miracle. I'm keeping it a buck. That's amazing in my book. That's going to be it for today, though. If you tuned in, thanks. If you're watching the VOD, what's up? Good to see you. Maybe you came here from a YouTube short. I'm going to put a couple new ones up. But yeah, that's going to be it from me for now. So thank you very much.